Let's start a new series of problems exploring fluid pressure. One of the things we're going to need when we measure pressure and use it for thermodynamic purposes is we're going to need to know the atmospheric pressure in which our pressure gauge is operating. And it isn't always possible to have a barometer handy. And so we would like to have a simple equation that would give us a standard barometric pressure for any elevation above sea level. We're well aware that atmospheric pressure varies with elevation, and there are multiple complex equations for calculating the barometric pressure. Here are two of them. They involve multiple variables. These are much more complex than what we would be interested in for our use in the study of thermodynamics. So let's explore something that's a lot simpler than this. Let's look at a simple algorithm which expresses standard barometric pressure in terms of altitude or elevation above sea level. This particular expression is in English units, and it states that at any elevation above sea level, the atmospheric pressure is going to be the standard pressure at sea level, given as 14.7 psia. That's pounds force per square inch. That's absolute pressure. And we're going to divide that by the exponential function of altitude over 27,000, both of those values in feet. The exponential function just means e to the power of altitude over 27,000. We also have a SI unit expression, which works in meters instead of feet. We find that the accuracy of these two expressions for elevations up to 10,000 feet is extraordinarily good. We get at least 3 significant figures, and we have no more than 0.5% error up to 10,000 feet. Let's solve a simple problem. What's the standard barometric pressure in Denver, Colorado, which is known as the Mile High City? We'll assume an altitude or elevation above sea level for Denver to be 5,280 feet or 1,609 meters. We'll use our simple expression and simply plug in 5,280 feet as the elevation above sea level and calculate that the standard barometric pressure in Denver is 12.1 psia. We can also do the same with our SI units expression, and we'll get a value of 83.3 kilopascals. And what we note is that both of these values are 82% of the standard barometric pressure at sea level. So as we increase elevation, we see that the pressure is reduced exponentially.